We're surrounded by stuff we use every day and never really think about. But sometimes the most common things hide the most brilliant engineering. So today, let's pull into a place you've probably been 100 times to uncover the complex, hidden world of the gas station.
Okay, so let me ask you something. What's the most complicated piece of technology you interact with on, say, a weekly basis? Is it your phone? Your car? I don't know, maybe your smart TV? Well, the answer might actually surprise you.
Believe it or not, it might just be the humble gas pump. Yeah, that handle you hold, the hose, the machine itself, it's this whole system that's packed with literally a century of incredible problem-solving and safety innovation. So let's dive in.
What we're really looking at here is a masterpiece of safety and mechanical engineering. This is a system designed from the ground up to handle thousands of gallons of a highly volatile, highly flammable liquid, and to do it with such precision and safety that we don't even think twice about it.
To really get how brilliant this is, you have to see where it all started. On the left, that's the early 1900s. People were literally using open cans and buckets to pour gasoline into their cars. The risk of fire was just astronomical. Now compare that to the right, a completely sealed, automated system with tons of safety features. It is a night and day difference.
So let's rewind the clock for a second. Before gas stations as we know them, getting fuel was a genuinely hazardous chore. You didn't just pull up to a pump, you might go to a pharmacy, of all places, or a general store where they'd ladle gasoline out of a big barrel into your can. It was messy, super dangerous, and just incredibly inefficient.
And you can see on this timeline just how fast things changed. We went from pharmacists selling gasoline almost like a weird side hustle in the late 1800s to the very first hand-cranked curbside pump in 1905. But the real game changer? That came in 1913 with the first drive-in station in Pittsburgh. This was really the birth of the gas station we know today.
So the engineers back then had some huge problems to solve. Fire was a constant, terrifying threat. Spills were happening all the time, which was not only wasteful, but a huge environmental issue. And on top of all that, you never really knew if you were getting the amount of fuel you actually paid for. These were the big challenges that had to be solved.
So the first truly revolutionary idea was this. Let's take the biggest hazard, tens of thousands of gallons of flammable liquid, and just bury it. Moving the storage tanks underground was a massive leap forward for safety, but it also created a brand new hidden problem.
And that problem? Rust. Simple as that. The early tanks were made of single-walled steel. And when you bury steel in damp ground, it is eventually going to rust. And once they rusted, they would leak, seeping gasoline directly into the soil and contaminating groundwater. A total silent disaster.
Okay, so how do we do it now? Well, the modern solution is pretty brilliant. Today's tanks are made of double-walled fiberglass. Fiberglass doesn't rust, ever. And that double wall creates a small space between the inner and outer layers, which allows for leak detection long before it can ever become a serious environmental problem.
All right, so the fuel is safe underground, great. But how do you get it into your car without spilling it everywhere? Well, let's talk about the part of this system we all actually touch, the nozzle. This thing is so much more than just a spout. It's basically a mechanical computer. It makes a critical decision, when to shut off, with no electricity, no computer chips, just some incredibly clever physics.
Which brings us to the million-dollar question, right? How in the world does the nozzle magically know to shut off right when your tank is full? Remember, there are no electronics here, no fancy sensors talking to your car. The answer is just a really elegant principle of physics.
And that principle is called the Venturi effect. Now, it might sound complicated, but the idea is actually pretty simple. When you force a fluid, like air, or in this case gasoline, through a narrow passage, it has to speed up. And as it speeds up, its pressure drops. That little drop in pressure, that's the key to everything.
Okay, so here's how it works, step by step. As the fuel is flowing out, there's a tiny tube near the tip of the nozzle that's constantly sucking in air, all thanks to that Venturi effect. Now, as your tank gets full, the rising gasoline covers that little hole. The airflow gets cut off instantly, and that creates a sudden vacuum inside the nozzle's handle. Finally, that vacuum pulls on a little diaphragm which is connected to the trigger, and click, it trips the shutoff valve. It is pure mechanical genius.
This one single innovation, the automatic shutoff nozzle, is what made the whole idea of self-serve gas stations possible. It pretty much made the process foolproof. It took human error out of the equation, which meant fewer dangerous spills, and allowed pretty much anyone to refuel their car safely and easily.
Okay, so now let's pull back a bit and see how all these different pieces, the safe tanks, that brilliant nozzle, all come together to create the complete system. Because it's not just one invention, it's a whole series of them working together perfectly every single time you stop for gas. It's really a symphony of hidden technology right under your feet.
So here it is, the whole ensemble. You've got the non-rusting fiberglass tanks keeping the fuel contained deep underground. You have powerful submersible pumps pushing that fuel up to the dispenser. You have the amazing Venturi nozzle preventing any overfills. And on top of all that, there's even a vapor recovery system, another set of tubes that actually sucks the gasoline fumes from your tank back into the station's storage, keeping them out of the atmosphere.
You know, there's this quote that just nails it perfectly. The whole goal of all this complex engineering, the pipes, the sensors, the mechanical triggers, is for you, the user, to never ever have to think about it. It's designed to be completely invisible, totally reliable, and to just work.
And that kind of brings us to a final thought, looking to the future. The gas station is an engineering marvel that was perfected for a century of cars with internal combustion engines. But as we start to transition to electric vehicles, you have to wonder, what can the charging station of tomorrow learn from the century of innovation that made the gas station so safe, efficient, and user-friendly? It's a really interesting question.